Hi, I'm David and this is the Biology Classroom. In this video, I will explain about what is standard deviation, how to calculate it, and how to use it to compare the means of two samples. Standard deviation indicates the spread of a set of data around its mean. The closer the value is to 0, the lesser those data spread around its mean. On the other hand, the larger the standard deviation, the more they deviates from the mean. Let's use an example to understand this. Now, we have two sets or two samples of data. Both set A and set B have the same value for their mean. However, you realize that the data in set A is pretty consistent and precise. They are almost the same with each other. This also means that each of the data is pretty similar to the mean of the sample. But look at set B. Some of the data are very big, some of them are very small. Each of them is rather far away from the mean. When you calculate the standard deviation for these two samples, you will find that the standard deviation for set A will be very small, or very close to 0, while the standard deviation for set B is larger. This is because, even though the mean values for both samples are the same, data in sample A is less spread from the mean. So, you can say that the mean value for sample A is more reliable compared to the mean value for sample B. This is the formula we use to calculate standard deviation in A-level biology. X means the observation or the individual data. X bar is the mean. N represents the sample size, or the number of observations you have in the sample. Let's use sample A in the example just now to try out this formula. We have 5 observations and the mean is 8. Find out the sum of each observation minus the mean squared, divided by the number of observations minus 1. The square root of this value is the standard deviation of the sample. Standard deviation can also tell us if the difference between the mean values of two samples are likely to be statistically significant or not. Let's say we have done a survey in two classes to find out the mean body height of the students. Class A has a mean of 169 cm. Class B has a mean of 173 cm. It seems like the students in Class B are taller than the students in Class A, as the mean value is greater, but the difference between them may not be significant. We can use the standard deviation to determine that. Let's say we did the calculations and find out that the standard deviation for A is 2.65 and the standard deviation for B is 3.51. You can now express the two means value as mean plus minus standard deviation. You are now having a range of where the mean can possibly fall, taking into account the spread of the data. For A, the range for the mean value is 166.35 to 171.65 cm. For B, the range is 169.49 to 176.51 cm. Now, you can see that the range of these two means overlap. Some values in the range for A is the same with the values in the range for B. The overlapping of the standard deviations means that the difference between the mean value of sample A and sample B is not significant. So the conclusion is, statistically, Class B is not really that much taller compared to Class A. The difference between their mean body heights is negligible. If you think my videos are useful, don't forget to like, comment and subscribe. Do share it with your friends as well. If you have any questions, feel free to ask me at the comment section. Thank you for watching and see you again soon.